Okay, good morning, everyone. How did the homework go? Do you guys had any difficulties with the homework? Any questions? Okay, as I said previously, the way we do it, you guys start your question, I answer them, and then we proceed. And your question should be from the problems that I have assigned to you from the book. Okay.
Can you go over question 23 for me, please?
23.
Yeah.
Yep, we're gonna do a lot of those problems. Yes, this I'm gonna do a lot of those. Any other questions? Okay, so 23, we're gonna practice it a lot today. All right, so anything else? Very good. So let us a little bit recall what we did. The unit circle definition of sine and cosine. All right, so just as you guys have those notes, but just to remind you. So what's the sine and cosine? We take a point P on the unit circle, and the unit circle is important because that's where we take our point, the unit circle, which is specified by the angle theta. It means, what does it mean specified or determined? It means the line OP form an angle theta with the positive x-axis. That's what it means determined. And so theta is the angle with the positive x-axis. Every word is matters in this situation. Cosine is, by definition, the x-coordinate of the point P. So whatever the x-coordinate of P, that's what the cosine of theta is. Whatever the y-coordinate, that's the sine of theta. So that's the picture that somehow it has to be honestly drilled in your head to be able to deal with the sine and cosine. So before we take up number 23 and problems along those lines, a very quick questions for you, and I'm gonna pick student. So I did that last time, but just to refresh, I'm gonna give you angles and you have to tell me whether the number is positive, negative, or zero. So suppose I give you sine of 100 degrees. And my question, is it positive, negative, zero? And I'm gonna pick one student. I would like the answer. Aziz, what can you say? Positive, negative, or zero? Are you with me? Aziz, are you with me? Okay, I'll pick another one. Asia. Okay. Are you guys with me? Can you hear me or not? All right, I'll pick another one. Anthony.
They're typing in chat.
What?
They're typing in chat.
Oh, I'm sorry. Thank you very much. Okay, so I didn't see the chat. I was listening. Positive, correct. Absolutely positive. And the reason, to explain why it is positive, you have to take the angle 100 degrees. So the point P is in the second quadrant. So the y coordinate is positive. Therefore, the sign is positive. Okay, so that's how we explain those ideas. All right, now what we're going to do is basically start working with problem like number 23 I've assigned. I will assign it again. So this is my question now. I will do the first two and then I will let you practice. Find an angle theta between 0 and 360 that have the same sign as 50, but different from 50. So now my question is, okay, I want an angle between 0 and 360 whose sign is the same as the sine of 50. So it have the same sign. So the sign is the same, but it's not 50, different from 50. So how are we going to answer this type of problem? So I will start the first one. So always the unit circle. As you realize, everything really boils down to unit circle. And this is my unit circle. 50 degrees is somewhere in here. So that's my 50 degrees. And the sine is right there. And that's the point P, which is determined by the angle 50. Now, my question is, I want you to give me another angle between 0 and 360 that have the same sine as 50, but it's not 50. What's the angle that have exactly the same sine, but not 50? How can we answer those type of questions? Anybody have any idea?
You can take the whatever the opposite quadrant for the sine and cosine is, and you can take the exact angle in that one. So for instance, the sine is also positive in quadrant 2. So you can take a theta angle of 50 in quadrant 2, and it should come out to be the same.
Okay. 50, you mean? I don't know. Okay.
So 140 degrees.
Right, that's
From-
makes sense. That's okay. So the idea is this is the point P. I'm going to take the point which is symmetric to it with respect to the y-axis, totally symmetric. I'm going to call it Q, totally symmetric. Okay, and I'm going to look at this angle. Okay, so I'm going to take Q, the point which is symmetric to P, with respect. So I usually write with respect, so you know, to the y-axis. Okay, so Q and P have the same y coordinate because I told so. Q and P have the same y coordinate. So what does this mean? It means, as your classmate said, if I take this angle, this one, theta, okay, then since Q and P have the same y coordinate, it means that the sine of theta is equal to the sine of 50. Okay, so that's really the theta that I am after. So the sine of theta is the same as the sine of 50. Now the question really boils down, what is theta? Okay, so what is theta? Again, we're using the symmetry of the unit circle, verbatim. So what is theta? If this is 50, this right here, watch carefully, this is also 50, total symmetry. So my angle theta is going to be 180 all the way. I take away the 50 from it, which is going to give me 140 degrees. Okay, so the angle theta, which is 140, so that's the 180 minus the 50, that's 140. So this angle and the angle 50 have exactly the same sign because the point P and Q have the same y coordinate, and that's exactly what the sign. Now you can check this on your calculator. What do I mean by that? So we can check this. I mean the following. Okay, as you know, your calculator evaluates the sine and cosine. So if I'm going to take my calculator and I'm going to compute the sine of 50, and I'm going to compute the sine of 140. Give me 1 minute.
Wouldn't it be 130 and not 140?
I'm getting, yeah, because your classmate said 140. I wasn't paying attention. Thank you very much. That's when I'm checked. I realized I'm doing something wrong. So thank you very much. So sine of 130, exactly 0.766. So the sine of 50, sine of 130, exactly the same answers. That's why I realized I was doing something off. Okay. Now, I want you to do the same thing, but the question is, find an angle between 0 and 360 that have the same cosine as 50. Okay, so question number 2 is, find an angle between 0 and 360 that have the same cosine. Cosine as 50, but of course different from 50. Okay, so again we're going to start with the unit circle. That's my unit circle, and that's the angle 50, exactly like I did before. And that's the point P determined by the angle 50. So now I want the angle who have the same cosine as 50. I'm having answers. Which point? So we know that the cosine of 50 is the x coordinate. It means whatever I get from here to here, that's what I get. All right, which point you guys are looking at? Alex, explain.
So basically we're, excuse me. Basically we're looking for the x coordinate that's similar between the two.
Okay, so which point you want to look at?
So what I looked at the 1,0 point at the 360 mark. And what I did was I subtracted 50 from 360.
You're right, but you want to be a little bit, I mean, you're right, but which point? I mean, you take the point, which point you're going to take here? That's the point that have the same x coordinate, right?
Yes.
Okay, so we're going to take Q, let Q be the point symmetric to P, sorry, with respect to the x-axis. Q and P have the same y coordinate as x coordinate. Okay. Now I'm going to look at the angle which is formed by that. So this is the angle. That's the theta. The cosine of theta and the cosine of P are exactly the same. And now what your classmate said. So we know the cosine of theta is exactly the same as the cosine of 50 because P and Q have the same x coordinate. So what is theta? Now I look at the picture. What is theta? If this is 50, this is down here 50 as well. So theta is going to be 360 minus the 50 degrees, which is 310 degrees. Okay, so that's really two angles. They have different angle, but they have the same cosine because of this picture, right? So now I'm going to want you to do two problems, basically along the same lines. I'll give you a minute to do each one of them. And those problems are, as usual, as worksheet on your on Brightspace, but I will put them in front of you. All right. A, B, that should be easy. So you guys have a minute to do them. So A is find an angle between 0 and 360 that have the same sine as 40, but different from 40. The second one is the same cosine as 40, the same cosine as 40. So please, you have like 2 minutes to do that, and then I will ask one of you for the answer. Get going. And please put your camera on. Okay. Okay, part A. I'm going to pick one of you for part A. Zebanika, did you get part A?
I'm still working on it, but so far for the point Q, I made it 40 degrees, and then I did 180 minus 40 and got 140.
You agree with her? Absolutely correct. She started with 140. Okay, let me get a good pencil. That's the 140. She's absolutely right. That's the point P. I want the same sign. It means I need to go symmetric with respect to the y-axis. If this is 40, this one from here to here is 180 minus 40. So that's exactly that's 180 minus 40. So the angle theta is 180 minus 40, which is this time 140. And you can always check. You can check. What do I mean by check? You pick up your calculator as is did before. You compute the sine of 40. Then you compute the sine of 140. You should get exact same answer. If you don't, it means you're doing something wrong. Okay. All right. B. A minute, and then I will pick a student. Caitlin, I did. What do you get?
So I put Q on the other side at 320, like I took it 40 degrees across the axis.
That's okay.
And then I made that Q, that point up there, Q.
Right.
And then I subtracted 360 from 40 from 360 and
Right.
got 320.
Okay, that's the angle we want. So this is 40, symmetry, tell me this is 40. So theta is 360 minus 340. Theta is 320. Okay, and we always can check. We always check to make sure. So I will check this one, and then after that, you guys will check. So the cosine of 40, that's what we got. And then the cosine of, where is my cosine? Cosine of 320. Exactly the same. So we have to make sure we're getting the exact same answer. All right, now C. C is the same cosine as 100. Okay, please get going. Again, you draw the picture and you give me the answer. Rebecca Zeman, do you have any idea?
I subtracted 360 minus 100 and I got 260. So it's a reflection across the x-axis.
Okay, so let's see what she did. This is 100. So that's 100, right? I mean, actually, no, shouldn't be here. 100 is a little bit, sorry. Okay, 100 should be somewhere here because this is 90, so this is 100. So this is my 100. That's my point P. And we actually want this one. That point right there, that's my Q. So the angle I want is from here to here. That's the angle I want. Am I right? That's my theta. P and Q have the same coordinate. It means the cosine of theta is the cosine of 100. And now she tried to compute theta using the picture. So I tell me, okay, to find theta, take 360 and take away the 100 from it. So she used the geometry of the picture. So she said, okay, take the whole thing and take away 300 from it, and you're fine. So their theta is 360 minus 100, which is gonna give me 260. So I repeat what she did. She went all around, which is fair, and then she took this 100 away, because by symmetry, this angle here, is exactly 100. That's 100, that's 100. So she took 360 minus 100. Is that clear? That's how she did the picture. All right, thank you very much. And then you can check it. You have to check it, make sure you're doing it. Okay, along the same lines, always, I'm not changing the picture. I will do D, and then I will leave it as a homework. D.
Being American is more than a pride we inherit. It's the past we step into and
Okay, please read D very carefully. Now I need the same sign as 220. Who's ready? Anybody ready?
Yes.
Okay, this time I will let you talk. Go for it.
If you're looking for the sine of 220, you have to look for the reflection across the y-axis.
So P is how far away it is from the x-axis. How many degrees?
40.
40, exactly. So 220 is 40 degrees away from the 180, right? So this is, we need almost 40 degrees. And it's important to know this because we have to really know. So from here to here, that's the 220. And the sign, it means that's the point P. That's the point P. Okay? Now, which point, what is Q? Keep talking.
Q is going to be at 360 minus 40, which will be 320.
It's going to be exactly right there. That's the point Q. It's going to be the symmetric for it because I want the same sign. The point here, whatever this value is, that's the sign of 220, whatever this value is. So the point Q is going to be right here. Okay. So my angle theta is from here to here. That's my angle theta. And now he's going to, your classmate computed it. Okay, what's theta? He said, okay, this little angle, how much is this little angle? 220. This little angle is 40 degrees. Okay, because we are, this little angle, this acute angle, that next hour we're gonna call it a name, we're gonna call it reference angle. But for now, this angle right here, this little acute angle is 40, because that's how far we are from 180. This is 220 minus 180, that's give me 40. So by symmetry, this is 40. Total symmetry. So my angle theta here is 360 minus 40, which is 320 degrees. Okay. Now, number 23 in the book is exactly those ideas. So I will assign it again for next time. So you guys get to practice this for next time. All right. Please ask questions. Okay. E, you finish it. Now I want to move to part 4. It's not hard, but it's important to know it. So I will explain part 4, and then I start asking you a question. Given to the right is a unit circle. Fill in the blanks with the correct answers in terms of A and B. Okay, so that's my picture. That's my theta. That's the point P. Okay, and now I have questions for you. And the answer should be in terms of A and B. Okay, so part A, for example. What do you think I'm expecting the blank to be? Matthew? Would you like to answer? What do you think the blank should be? That's the angle theta. What's the sine of theta in terms of A and B? Anybody else? That's okay, don't worry. Anybody else?
B.
A, exactly, because that's the x coordinate. So that's, no, not A, be careful. The sine, what's the sine of theta?
It's B.
Sine is
B.
B, why? Because the sine is
Y.
the y coordinate. Okay, though that's B, so be very careful. So this is my point theta. I'm gonna call A and B. The goal is to remind you the definition of the sine of theta. What's the sine? It's the y coordinate, whatever it is. If I call it B, fine, this is gonna be B. So this here, that's the sine of theta.
So
Now, go ahead.
they weren't asking us to solve for theta here. I was
Absolutely not. No, you cannot solve for it. You don't know anything. It's
Right.
just fill in the blank in terms of A and B.
Okay.
You read the
Okay, that's
question?
simple, yeah.
That's it. That's it. Cosine theta, you answer. What's going to be? Okay, I'll pick student arbitrarily. Samantha.
Oh,
It would be A.
It has to be A. Because A, that's the x coordinate. That's the cosine of theta. Now, sine of theta plus 360. What's going to be? Who would like to answer? We have to draw the angle. Theta plus 360. Where is it? Theta. Add 360 to it. We're back to the same point. Okay, so what's the sine of theta plus 360 in terms of A and B? I'm after the point P that form an angle theta plus 360. So what is the point P? That theta, I add 360, I come back to the same point.
Wouldn't it be B again?
It's gonna be B again. It's gonna be exactly B. It's the same point. It's exactly the same point. What about the cosine? Sorry. Oh, very good. So that's exactly B. Now, sine of theta plus 180 and cosine of theta plus 180. I want you to think about that. What's going to be in terms of A and B? This one, I'm going to give you a little bit of time to think through it. Remember, I need to find what's this angle here. Draw this angle and then think about the coordinate. Each one of you, please, I want every one of you to work with me. Theta plus 180. Where is this angle in terms of theta? Anybody ready? Okay. Anybody ready or shall I pick? Okay, I'm giving answers. Okay. All right, I'm getting minus B. Let's see if the minus B is correct. So I drew another picture so to be more clear. I want theta, the sine of theta plus 180. The only way I can do it is I have to take the angle theta plus 180 and then find its x and y coordinate. If this is theta, if I add 180 to it, it means I'm going to end up right here. So this is the angle 180 plus theta. That's the angle. Okay. Now I want the sine. It means that's the sine. That's our definition. So this is the sine of 180 plus theta. Now in terms of A and B, what's this point here? In terms of A and B, if this is A and this is B, by symmetry, what's this point? It's minus A minus B because I have total symmetry. So this is going to be minus A and this is right here is going to be the minus B. So total the symmetry of the circle. So I want theta plus 180. I have to look at this point Q. What are the coordinates? If this is AB, this is minus A minus B. So this tells me that the sine of 180 is minus B. The cosine is minus A. Okay, over and over, we're emphasizing those definitions. All right, now I want you to do F. Exactly the same thing. You draw the angle and just ask yourself, what is it in terms of A and B? So F, all of you, then I will pick a student. Okay, can I see any answers? Anybody got any answer?
It's going to be negative.
Negative? Speak up, I can't hear you.
A.
A, absolutely, because what is 180 minus theta? If this is theta, 180 minus theta, it means you're taking theta here, the same value, and this is 180 minus theta. This angle is 180 minus theta. So I want the coordinate of this point because I want the cosine. What are the coordinates? By symmetry, if this is A, this is minus A. The y is the same. So that's minus A and B. So the cosine has to be minus A because the cosine is the x coordinate. Now, G. I want cosine of 360 minus theta, G and H. Again, you have to draw the angle, 360 minus theta, tell me its x and y coordinate. Okay, I want you to do it, and then I will pick one of you. Okay. Ready? Okay, Phoenix, what do you think? Phoenix, are you with me? Okay, Phoenix is telling me minus BA. Is he correct? 360 minus theta. It means you're taking 360, you're taking away the exact same theta. Right there. So that's the 360 minus theta. Minus theta. It means this point here is, the A is the same. No, be very careful. Be very careful. What's your answer? Right. A is the same, but the B is the opposite. So this point is minus B. Good. Now, what's the cosine then? Now I want you to fill the blank here. The cosine is what? Phoenix, keep going. What's the cosine? Put it on chat. It's okay with me. The cosine is, no, you're confusing it. What's the cosine? The cosine is which coordinate? The cosine is the x coordinate. What's the x coordinate here? A. Cosine is the x coordinate. It means it's A. If you write x, I will not accept it. I want it in terms of A and B. So it is A. The y coordinate, the sine is the y coordinate. So that's the sign right there, which is the minus P. Okay. So we have to be very, very careful. Okay. Any questions? Please go over this worksheet very well because it's really setting the stage for a lot of things you will be doing. Questions before I move on? So now we're going to, of course, we're doing a lot along the same line. So now my question is, you know that our calculators, as I said, compute the sine and cosine. And the way they compute them is, and they use the same idea that we developed because that's the definition. And they have a specific algorithm to be able to compute the value of sine and cosine. And now we are going to use those values to do the following. Coordinate of a point on the unit circle. So how to find coordinate of a point on unit circle. So basically now I'm going to go backward in a way. I'm going to give you the angle and we have to find the coordinate. So we're going to move backward. So what's the idea? Just moving backwards. Suppose you have a unit circle and the word unit is absolutely crucial. the unit circle. And I have a point P on the unit circle. It could be anywhere. So that's my point P. And it's determined by the angle theta. Okay, P is determined by the angle theta. So P determined by theta. So what are the coordinates of the point P in terms of sine and cosine? So as I said, we're moving backward now. I'm giving Q to theta, and I want to find the coordinate of B. In terms of sine and cosine, this is cosine theta, and this is the sine of theta. This is the sine, and the y coordinate of the point P is the cosine of theta. And so how do we use, and this is the unit circle, 1, 0. How do we use these ideas? And we use this a lot. So for example, I ask you the following. Find the coordinate of the points P determined by the given angle. The point determined by the given angle on the unit circle. And unit is crucial because if we don't have the unit circle, the picture will change a little bit. So what do I mean by that? So theta equal 100 degrees. What do I mean? Find the coordinate determined by the given angle on the unit circle. What I mean is the following. I'm going to take the unit circle. Sorry, assume this is a unit circle. And I'm going to take 100 degrees. Here. The question is, find the coordinate of this point. That's really what the question is. So the coordinate of this point is the x coordinate, this one, is the cosine of 100. So now we're moving, going to move backward in a way. And the y coordinate is the sine of 100. So this point has for coordinate cosine and the sine. So let us find them. That's the cosine, which is equal to, and now we're going to use our calculator for that. So the cosine is cosine of 100. That's minus 0.173. So we find them up to 3 decimal places. And we expected a negative answer. The y coordinate is the sine of 100. And now I expect a positive answer. So let's see if we could get that. So the sine of 100 is 0.984. So in those problems, we're moving in a way backward. It means I give you the angle, and you have to find the x and y coordinate. And the x, y coordinate are the sine and cosine. So it means the point P has for coordinate minus 0.173, 0.984. Okay.
I have a general question, if you don't mind.
Yes, of course.
I noticed that you didn't round up or round down when you didn't look to the fourth coordinate on the decimal.
Yeah. Usually I will tell you how many decimal places. You can round. It depends. Round up or round down, depending whether that's a 3 or 6. Okay. If this is a 3, you round down. No, I mean you have to check what this number is.
Right. So in your 0.984, it was a 0.9848, I believe.
So you can do 5.
I just wanted to know if you wanted to do rounding or not, because that would change our answers.
Yeah, round. I don't know how what the book does for answers. I should check that. Round it to the 3rd decimal places.
Okay.
Okay, very good, thank you. All right, so that's the idea for the unit circle. So now I give you the angle, you have to find the point. This is true as long as I have a unit circle. Now, what if I have a circle which is not a unit circle? So find the coordinate of a point on a circle of radius r. So find coordinate of points on a circle of radius r. It's not unit anymore. How the picture will change. So let's see what I'm talking about right now. I'm talking about the following. Suppose we have a circle, but this time the circle is not the unit circle. Okay, that's not the unit circle. Okay, so this is a circle of radius r. It means if this is 0, from here to here I have r. So this is r0. And I have a point on the unit circle, sorry, on the circle radius r. This is my point, I'm going to call it q, determined by an angle theta. And the question is, what are the coordinates of this point? It's not cosine theta, sine theta, because cosine theta, sine theta only on the unit circle. That was our definition. It means if I had a unit circle here, I had a unit circle here, this is the unit circle, and I take this point P, this is cosine theta, sine theta, as long as I have a unit circle. But now when I have a circle of radius r, what will happen to the coordinate? Can anybody give it their best shot? So remember now here, this is r. So the x and y coordinate now are going to change. On the unit circle, you have cosine. When I take a circle of radius r, by similarity, this is going to become r cosine theta. It means the x coordinate, since we're stretching OP by r, we're stretching it, the x coordinate, instead of being cosine theta, now it's going to be r cosine theta. And the y coordinate, instead of being sine theta on the unit circle, it's going to be r sine theta on the circle of radius r. So if we have a circle of radius r, and we take a point that form an angle theta, the cosine and sine would be stretched by r. So this is going to become, the point Q is going to have a coordinate r, the radius cosine theta, the radius sine theta. So on the unit circle is cosine theta. We stretch the unit circle, so we take a circle of radius r, then the x and y coordinate will have to be multiplied by the radius. So a very straightforward example. So suppose I tell you, find the coordinate of the point Q, determined by the angle 100 on a circle of radius 4. Okay, so what's the picture now? The picture now is the following. This is radius 4, so it's not the unit circle anymore. And my angle is 100. Be very careful, this is not the unit circle. That's 4, 0. That's my angle, theta, which is 100 degrees. My question is, find the coordinate of Q. If my circle is not the unit, the coordinates are going to be, the x coordinate would be r cosine of 100, and this would be r, where my r is 4, the sine of 100. So that will be the change. So now the x coordinate is r, which is 4, that's r, times the cosine of 100. And we will find it in a method on a calculator. The y would be 4, the sine of 100. So the point Q is, I write it clearly and then I plug in values in my calculator. That's the easy part. 4 sine of 100. So the idea is that when, for the unit circle, the definition of sine and cosine are the x and y coordinate. When I stretch the circle, then I have to multiply the x and the y by the radius r. So now the last step is to compute those. So, okay, 4, so I do it in front of you. Cosine, where is my cosine? That's my cosine of 100. That's minus 0.6945. So 9, so we're gonna round it up to minus 0.695. So we're gonna round it up, minus 0.694, actually 46. Let me round it up to 4 decimal places. Now the other one, 4 sine 100. I'm going to also round it up to 4 decimal places. It's 3.9392. So 3.9392. So I'm rounding to 4 decimal places. So finally, this will be equal to minus 0.6946 and 3.9392. Okay. So that's what happens. That's how we can use the value of sine and cosine to find values of the coordinate of the point on a circle of radius r and on the unit circle. Okay, any questions so far? Okay, today, because it's the first day we're taking the quiz, I'm going to stop here. And please make sure you do the assignment for Monday. Please do the homework. It's the only way you're going to learn this material. Okay, so the quiz. How are we going to do the quiz? I want you all to go to Brightspace. Okay, I'm going to share the screen with you. I want you all to go to Brightspace. Okay, and let me go to Brightspace myself. Very good. All right, go to the content area. All of us. Are you with me? Yes or no? Scream. On the content area, you go to quizzes and exams. Click on it. You see quiz 1. Click on quiz 1. You see this. And that's your quiz. All right, now, if you have a printer, you want to print it, go ahead. If you don't have a printer, I cannot force you to have a printer for sure. It's all right. Then I want you to take a clean sheet of paper, very clear. Write the answers on the sheet of paper. Number the problem. And here I forgot to put A and B, my apology. The first graph, it's A. The second graph is B. Write your answer very clearly, okay, for all of them. And then once you're done, upload it into Brightspace. As a PDF document, it will be the best for me. Get going. Get started. When you're done, you leave. Okay? And if you have any questions, put it on chat privately. Don't talk because it will bother the rest of the class. And I will answer you on chat. Good luck. Get going. You don't have till the end of the day. No, you have till 12:30. 12:30 it should be in. Okay.